if for two variables x and y, the covariance, variance of x and variance of y are 40, 16 and 256 respectively, what is the value of the correlation coefficient? The formula to find out correlation coefficient R is equal to covariance of xy divided by sx into sy is equal to, now the covariance is given here 14, 40, so it is 40 divided by, see s of x will be 4 because 16 is the variance of x, so the standard deviation will be square root of 16 which is 4, and into the standard deviation of y will be 16, so it is 40 divided by 64. Now let's just solve it by calculator. It is 40 divided by 64 which is equal to 0.625. So our answer is B, 0.625. If covariance of xy is equal to 15, what restriction should be put for the standard deviation of x and y? The formula of correlation is covariance of xy divided by standard deviation of x, that is sx, into standard deviation of y. Now the covariance is given to us 15 and we are required to think something about the denominator, that what restriction we should put here to the multiplication of sx into sy. Now let me make you remember that R always lies between -1 and +1. It can be equal to also, but generally it lies between -1 and +1. So in this case, if my multiplication of sx and sy is a number less than 15, then the answer would be greater than 50 or greater than 1, which is not possible here. So what I can say is the multiplication of sx into sy must be greater than 15. It can be equal to 15 also, but in general case it must be greater than 15. So our answer here in this case can be the product of standard deviation should be more than 15. So the answer is B here. If the covariance between two variables is 20 and the variance of one of the variables is 16, what would be the variance of the other variable? R is equal to covariance of xy divided by sx into sy. Now suppose covariance is already given to us 20 and suppose variance of one variable, and that one of the variable is nothing but x. If the variance is 16, then the standard deviation must be 4. We have to think about the restriction which we can put on the standard deviation of y. So can you just find it out? This sy should be equal to 5, so that we can get 20 in the denominator, 5 into 4. Or it should be greater than 5, so that we can get the multiplication greater than 20 here, and the answer of R will be below +1. So there are two possibilities here. Either sy should be equal to 5 or it should be greater than 5. So now we are actually required to comment on the variance of the variable, and this is actually the standard deviation. So my variance, that is sy square, should be either 25 or it should be greater than 25. So here let me correct the answer. More than 10, let us correct this 10 and put 25 here. So I can say my answer is B. There is some kind of printing mistake in the sum. The answer should be more than 25 only. So you can correct that. If y is equal to a plus bx, then what is the coefficient of correlation between x and y? So here the question is very simple. Correlation actually measures the linear relationship between the two variables, and here we have already been given that if y is equal to a plus bx, that does mean the correlation is going to be either positive 1 or negative 1. Now why it is positive and negative 1? See, this depends on the slope. It may be possible that the value of the b, the value of the slope here is positive, and it may also be possible that the value of the slope here is negative. So if the value of the slope is a positive value, then r is going to be plus 1, and if the value of the slope is negative value, then the r is going to be minus 1. So our answer here is C, 1 or minus 1, according to b is greater than 0 or b is less than 0. This is nothing but the positive value, and these are nothing but the negative value. If r is equal to 0.6, then the coefficient of non-determination is. Now the coefficient of non-determination is 1 minus r square. So here it is 1 minus 0.6 square. So it is 1 minus 0.36, which is 0.64. So our answer is D. If u plus 5x is equal to 6 and 3y minus 7v is equal to 20, and the correlation coefficient between x and y is 0.58, then what would be the correlation coefficient between u and v? Let me first write down the equation here. U plus 5x is equal to 6 and 3y minus 7v is equal to 20. So here you can see one equation is showing us the relationship between x and u variable, and the another equation is showing us the relationship between u and v. Now the most interesting thing is that correlation is actually free from change in origin and also from change in scale. So we can forget here this 6, this 20, which both shows the change in origin. We can also forget about 5 and 7 and this 3, which shows us the change in scale. So now our equation is converted into a very simple format, that u plus x is equal to 0 and y minus v is equal to 0. Let's further simplify it. So u will become minus x and y will become plus v. So if we just make a pair here of both the variables u and v, then we can relate u is equal to minus x and v is equal to plus 1. So we can say, if you want to find out the relationship between u and v, or the correlation between u and v, then we can compute the correlation between minus x and y. So suppose the correlation between plus x and plus y is given 0.58, then naturally if I change the sign of one set of variable, then the sign of correlation will also get changed. So my answer here is nothing but 0.58, but negative 0.58. If the relation between x and u is 3x plus 4u plus 7 is equal to 0, and the correlation coefficient between x and y is minus 0.6, then what is the correlation coefficient between u and y? The relation between x and u is given by the equation 3x plus 4u plus 7 is equal to 0. Now as the correlation is free from change in origin and free from change in scale, we can forget about this plus 3, we can forget about this 4 and also about this 7. So now the relation of x and u is just x plus u is equal to 0. So we can also say x is equal to minus u. Now the correlation coefficient between x and y is r of x and y is minus 0.6, and what will be r of u and y? This has been asked to us. Now here if I say x is equal to minus u, then I can also say u is equal to minus x. So this u will actually become minus x. So what I can do, I can write this thing as r is equal to minus x and y. Just see, the sign of one variable has changed. So the sign of correlation will also change. So this is going to be 0.60 positive. So here in this case our answer is 0.6 positive. From the following data, 2 coefficient of correlation was found to be 0.93. What is the correlation between u and v as given below? Let us find out the change which they have made to make x or to transform x into u. You can see here that from each and every variable 5 has been deducted. So 2 minus 5 is going to be minus 3, 3 minus 5 is going to be minus 2, 5 minus 5 is naturally 0, 4 minus 5 is minus 1, and 7 minus 5 is equal to 2. So there is a change of minus 5 from each and every observation, and y has been or 8 has been deducted from each and every observation of y. So 4 minus 8 is minus 4, 6 minus 8 is 2, 7 minus 8 is minus 1, 8 minus 8 is 0, and 10 minus 8 is equal to 2. So there is a change of minus 8 in all y, minus 5 in all x, and minus 8 in all y. So what kind of change they have made here? Yes, it is a change of origin, and change of origin is actually not relevant for the correlation. So I can very easily say that if the correlation of x and y is 0.93, then the correlation of u and v will also be 0.93. So our answer here is B, 0.93. Referring to the data presented in question number 8, what could be the correlation between u and v? Again, let me check what they have done to transform x into u. Here it is 2, here it is 10, so we can say all the x's have multiplied by 5 here. 2 into 5 is 10, 3 into 5 is 15, this 5 into 5 is 25, 4 into 5 is 20, 7 into 5 is 35. And what they have done to transform u into v is they have just multiplied it by minus 6. So here all x have been multiplied by 5 and all y have been multiplied by minus 6. What kind of change is this? This is a change in scale. We also know that the correlation is not dependent on change in scale, but the most important thing which we should keep in mind here is that this minus sign. We have no any problem if the y has been multiplied by 6 here, but this minus will create a bit problem. This will reverse the direction of the change, and we know the correlation measures two things. One is direction and one is magnitude. There will not be any change in the magnitude here, but the direction will definitely change. So the answer sign will change. So if the correlation between x and y is 0.93, then the correlation between u and v will be minus 0.93. So our answer will only differ in sign, and it is minus 0.93 here. If the sum of squares of difference of ranks given by two judges A and B of 8 students is 21, what is the value of rank correlation coefficient? Rank correlation coefficient is equal to 1 minus 6 sigma d square divided by n into n square minus 1. So here in this case it is 1 minus 6 into sigma d square. The sum of squares of difference of rank is given 21. So 21 divided by n is 8 into 8 square minus 1. So this is 1 minus 126 divided by 8 square is 64, 64 minus 1 is 63, and 63 into 8 is going to be 504. So let me just solve it by using calculator. 126 divided by 504 is equal to 0.25, and you deduct 1 from here, then it will become minus 0.75, but we have to change the sign here because we deducted 1 from this answer, so our answer is positive 0.75. So our answer here is C. If the rank correlation coefficient between marks in management and mathematics for a group of students is 0.6 and the sum of squares of the differences in rank is 66, what is the number of students in a group? Again, let me put the formula of rank correlation. It is R is equal to 1 minus 6 sigma d square divided by n into n square minus 1. Let me fill all the figures here. So it is 1 minus 6 into the square of difference in rank is already given as 66 divided by n is not given to us, so it will become n into n square minus 1 only, and the rank correlation is actually given 0.6. So now what we can do is we can take this 0.6 on the left side of the equation and it will be deducted from 1, so we will have 0.4 is equal to 66 into 6 is going to be 396 actually, and divided by n into n square minus 1. So n into n square minus 1 will become 396 divided by 0.4. Let's solve it. It is 396 divided by 0.4 is equal to 990. Oh, we can definitely just find out the value of n now. It is 10 only, because if it is 10 then only the answer can be 990. We can just use the trial and error method also. Just take all the answers and put in this in place of n, and if you are getting 990 then generally that is your answer. So our answer is A here. While computing rank correlation coefficient between profit and investment for the last 6 years of a company, the difference in a rank for the year was taken 3 instead of 4. What is the rectified rank correlation coefficient if it is known that the original value of rank correlation coefficient was 4? So it is a question about some mistake which we have made at a time of computing the rank correlation coefficient. Let me put the formula. R is equal to 1 minus 6 sigma d square divided by n into n square minus 1. Let me fill all the figures which are given to me. R is 0.4 given to us, is equal to 1 minus 6 sigma d square is not known to us, and n are actually 6. So it is going to be 6 into 36 minus 1. So this is 0.4 is equal to 1 minus 6 sigma d square divided by 36 minus 1 is 35 into 6 is 210. So now I can say, let me take this one on, let me take this whole expression minus 6 sigma d square divided by 210 on the left side and this 0.4 on the right side. So I can say 0.6 is equal to 6 sigma d square divided by 210. So that's why 6 sigma d square is equal to 126. So sigma d square will become 21. Now we know that this sigma d square is actually wrong sigma d square for us, because rank was taken 3 instead of 4. So now we have to find out the right sigma d square, and to find that we will do a modification here. 21 plus 16. The 16 is a square of the right rank 4 and minus 9. This is the square of the wrong rank taken 3. So our new sigma d square, our sigma d square new will be 21 plus 16 minus 9 is equal to 28. So this is new sigma d square, or I should say this is right sigma d square. Let's again apply the formula. R is equal to 1 minus 6 into 28. Yes, the new sigma d square divided by n into n square minus 1 can be written as 210 only. Let us solve it by using calculator. So it is 6 into 28 divided by 210. This is 0.8. Let me just write 1 from here and then just change the sign of it. So our answer is 0.2 here in this case, which is B here.